Hi, today we are going to talk about CAP Theorem, which is a fundamental concept of system design that emphasizes the trade-offs and limitation of a distributed database. So let's get started. We have these three parameters: consistency, availability, and partition tolerance, that a distributed database cannot achieve all these three properties at the same time. So, the databases have to trade off between one of the three and achieve any two of them. Examples of databases having consistency and availability is RDBMS, consistency and partition tolerance, databases like Bigtable, HBase, partition tolerance and availability, databases like DynamoDB, Cassandra, and CouchDB are good examples of it. Let's look in detail at each of them. So, firstly, talking about the consistency, it implies that all the nodes see the same data at the same time and every read receives the most recent data. So, covering the first statements, if there is a user A and user B, they try to access our application and try to read the inventory. So the application might get the data from two replicas, replica X and replica Y. So if A and B are querying the application at time X, they should be able to get the same product with same quantity at that particular time. The second statement has to do more with reads and writes. So, say for example, person A comes in and updates the inventory in our application and adds the product P. So, it writes into the replica X that product P is added to the inventory. But then we have another replica Y. Now this happens at X time. Now if user B comes in and tries to read the data at X plus 1 time, he should be able to see the product P even if the request goes to the Y replica. So the product P should be added at the same time to the Y replica, and when the user B makes a request to read the inventory, it should also be able to see the product P. Moving on to availability, it states that the system is always operational and every request gets a response even if it is not the latest data. So, say for example, we have an online social media application. A goes in and post an image. Post an image and it gets saved in the X replica of our dataset, but the Y replica still doesn't have it. When user B makes a request, the application should be up and should fetch all the data from the feed and respond back to B, even if the other replicas don't have the information about the post P made by the person A. Moving on to partition tolerance, the system continues to operate despite network failures or communication breaks between the node. So partition tolerance is the underlying requirement for having a distributed database. If the partitions are disconnected when there is a network failure, they can't be distributed. So a distributed database requires to be partition tolerant. The tug of war lies between the consistency and availability. Consistency prioritizes being correct. It may or may not be up and running all the time. But availability prioritizes being online. It will always respond to a request even if it is not the latest one. Now let's look at some of the availability first applications. Social media platforms are obviously the one prioritizing availability rather than consistency. Netflix recommendations, say for example, we have a new movie release which is not yet like which is we have a new movie release, but then for some users it is reflected, but for some of them it is not yet reflected. So it is there is no harm in having Netflix giving incorrect recommendations, but there is a harm if Netflix goes down. Content delivery networks, same if there is any content management application or blogging application. It is not important to have the latest blog, but it is important that the application is online all the time. Amazon shopping cart, if there is new product release, it is not important that all users can see it. It is important that the Amazon application is up and running and live all the time. Now let's have a look at some of the consistency first applications. Bank account balances are a crucial thing which cannot be wrong. The banking application can go down for some time, but users can't afford to see incorrect balance in their account. Financial transaction, say for example you have done a 1 million transaction, you cannot afford to not see it. Rather, it is okay that the bank server goes down and it does not show any transaction, but when it comes up, it should show the transaction, the latest transaction that you have made. E-commerce inventory. So there is a problem if a user places an order for an item that is not available. So inventory should be always correct. Even if it is not available for some time, that is fine, but it should not have incorrect data. Airline or a railways reservation, user should be able to see the correct data, and it should not be that the tickets or seats are booked, still user is able to see some of the seats unbooked and proceed with the reservation, and then get to know that their transaction or their booking cannot be completed. So the trade-offs between consistency and availability is not a very black and white thing. A software engineer should try to minimize the trade-off that they are doing. So if a system is highly consistent, that does not mean that it should always be down. So there is a lot of gray area between the two, and it's not a very straightforward binary selection. PACELC theorem is an extension of CAP theorem, which emphasize more on the scenario when there is no partition fault, or when there is no partition in the application. So when there is a partition and there is a partition fault, CAP theorem stands true that consistency or availability, either one of them should be chosen. But when there is no partition, on the other hand, the two parameters on which our application is trading off is mostly latency and consistency. So if the latency, if the application is fine with high latency, it can have consistent data. But if we aim to have a low latency application, it will not have consistent data all the time. So this was all about the CAP theorem, how it explains the trade-offs when building a distributed database.